Hi all, in this week, week 3, we are going to begin chapter 3. The title is Fluid Statics. Okay, so you have learned the whole subject of statics in probably your SEM 2. And this is a little bit different because we're dealing with fluid bodies. And as you know, it's difficult for a fluid body to remain static. So the cases are very few in comparison to rigid bodies. The content of this subject includes hydrostatic forces on submerged plane surfaces. So we're going to see what is hydrostatic force and how do they act on the submerged plane surfaces. Right, so there will be three cases that we will look into, the horizontal plane, the vertical plane, and the inclined plane. Next, we are going to look into buoyancy and stability. Right, so in this video, we're just going to cover the introduction for you to learn about the definition of the title and also to tackle the first part, which is the horizontal plane, which is actually very simple. Now, look at this dam. Okay, this is a water dam. And if you notice that the wall here, right, is thicker at the bottom compared to the top. So why do you think the wall has to be thicker at the bottom? The answer to that is the pressure of water or a fluid body, in this case it's water here, is always higher at the bottom. So this is in line with what you learned in the previous chapter, which is P equals to rho GH. So the term H there influences the overall pressure in the water. So whatever pressure in the water, it is causing hydrostatic forces. Okay, as you know, force and pressure are related. So the definition of this title is simply hydrostatic forces, which are forces created by a body of static fluid, in this case water. Let's just say water for to make it easy. Okay, in a body of static water, you have forces acting on submerged plane surfaces. So plane is just a plane, right? It's a thin body, something like a wall or a plate underwater. Submerged here means that it is completely underwater, or at least part of it is submerged completely. So as I said, in this video, we're only going to cover horizontal plane. So let's take this example. Yeah. So you have a pool. Let's just say this is a pool. This surface is open to the atmosphere. Therefore, P is PATM. This is also called free surface. That means it's not being covered with anything. Okay. So horizontal plane, obviously, we only have one here, which is the base of the pool. Okay, and you can see that on a plane surface, the hydrostatic forces form a system of parallel forces. Okay, so all these small arrows, these are parallel forces. Okay, and it's equally spread onto the surface. What causes this? What causes this is the pressure. Where does this pressure come from? This is from chapter 2, P equals to rho GH. So whatever pressure at the bottom, that is the pressure that is pressing on the surface here. And this pressure is related to the hydrostatic force. Okay, they exist together. It's not the pressure causing the force or the force causing the pressure. They exist together. When you have force exerted on an area, you have pressure. Okay, so from this equation, the pressure at the bottom, as I mentioned just now, is rho GH. So it's very simple. Rho is the density of this fluid, G is gravity, H is whatever height you are dealing with. And it's uniform on the entire plane. Let's just say this is this height is the same across this pool of water. All right. Therefore, the pressure is uniform and the resultant force, okay, so you see this larger arrow here, is the resultant force. If you recall in your statics, whenever you have small forces like this, okay, parallel forces, you can have a resultant force at the center of it. So this is the equivalent force, yeah. So resultant force, we call it Fr equals to, from this equation, F equals to P times A. So we have Fr equals to P times A. And the P is this rho GH. Therefore, Fr equals to rho GH times A. And A is, of course, the area of this plate or the bottom of this container. So if it's circular, then it's a circular area. If it's square, then it's a square area. So that is for horizontal plane. In the next video, we're going to cover something a little bit more complicated, which is the vertical plane.